Okay, so remember, to identify it as an ellipse, it has to have an x squared and a y squared, and it has to have a plus in between. It's kind of almost similar to a circle because a circle is a special kind of ellipse. So what we have here, when these two are equal on the bottom, we have a circle. It goes out and up and down the same amount of distance if it is a circle. An ellipse, and we want our equation set to 1. A, you find by your larger number, and B is your smaller number, and C, you have to use the formula. So again, this is your x minus h squared, y minus k squared. Your vertex, pull that out, pull out your A, B, and C. It helps to do this. Make all your letters because you need to know those. A is the distance from your vertex, from your major vertex, from your main one, to your center. B is the distance from your co-vertex, your minor one, to your center. And C is the distance from your focus to your center. Okay? Everybody was okay with the first one? Okay? We kind of did this one in class, I think, right? Did we do this one in class together? Okay.
Number 7, yeah. We didn't do number 9.
Right, number 7 we did. Okay. Now, your major axis is the guy that has the bottom number the largest. And that's where the oblong goes. Number 9, almost the same setup, but we switched the numbers around. So now your major axis is your y, your vertical axis. So that's where it's more oblong. So now, same thing. Your center is at 0, 0. Your center does not sit on your ellipse, just like a circle. It's the center. Find your A, 5, B, 4, C, use your formula, and find C. So now, your foci sit equal distance from your center. This is C, this is C. Well, distance, positive distance. Just figure out. Try not to memorize those formulas. Try to figure it out off your graph. It makes more sense. Vertically, I'm changing my y. So I'm going to drop this guy 5. I'm going to add this guy 5. So, 3. What was I say? 3. I'm going to drop the 3 and add the 3. Do the same thing with your vertex and do the same thing with your co-vertices. Don't forget, your vertex is on your major axis. Your co-vertices is your minor axis. It's like a pilot and a co-pilot. Stop me if you have any questions.
But how can you tell when it's vertical and horizontal?
Whichever number is larger on the bottom, look at the letter on top. So 25 is bigger than 16. So y? Y's go this way. So it's a vertical one. It's going to be oblong this way. The first one, x had the larger number. It was oblong this way, around the x-axis. Think of it like an axis. So whenever I see the y, I see my y-axis, even if it's translated somewhere here or here, it's still going to be a vertical, longer one than wider. It's like stretched this way. Okay? Okay. Number 11. Now, number 11, we threw a little radical in here. You have your A is the square root of 9, 3. You have your B, which is radical 5. And it has to stay radical 5. But it works the same way as adding 3 or adding 4 or adding 5. You just add radical 5. Now, when you get here, here's your center. Now, here's your larger number, 9. So, Vanessa, X is my major axis. This X-axis is my major axis. This is my major guy because X has the larger number in the denominator. Okay, so now, let's do your center 0, 0. You're moving out 3, so 3, 0. Out 3 to the left, negative 3, 0. There's your vertices. Oh, yeah. Okay, co-vertices, doing the same thing. You're moving up radical 5. So 0, radical 5. Down radical 5. 0, negative radical 5. That is the only thing you can do. Just leave it like that. That's fine. Focus, has to be on the major axis, on the x-axis. So you're moving over 2. So 2, 0, negative 2, 0. I put the formulas there as well, but try to use your graph rather than, you almost have to think about your graph when you're thinking about the formulas anyway, because you got to know which way to add or subtract from. So you might as well just do it off the graph. Questions? This is something very new, ellipse. Okay. All right, now we have one that has a vertex that's off-center. It's a translated vertex. When you see your vertex as 1, 5, from 0, 0, I move over 1, up 5. So now, make your new axis like this. It's a translated axis. I just shifted my center over and up. So your major axis is still the guy with the larger number. 25 is bigger than 9, so Y, a vertical axis, is my major axis. It's just shifted over here. So keep track of this center. I think it helps if you write it on there, because then you can visualize. Take your square roots, use your formula for C. These are your important parts. So now, my vertice says my Y is moving. My Y is moving 5 units down to the 1, 0. 5 units up to the 110. To the, oh my, I don't know where it is. 110, here it is. Okay, my co-vertice is my B. It's moving 3 over. 3 over puts me at 4, 5. 3 over puts me at negative 2, 5. There's my co-vertices. And my foci have to sit on my major axis. 3 up and down. 4 up and down. Okay. Not a lot to know about these, just a little bit of basic information. The major, the minor, they're for the vertices, the co-vertices, the foci, and the center. Those are what we really identify with your ellipse. That's probably the extent of what we do with it. You see like your running tracks and all, those are ellipses. Those are ellipses with a regular center in them. Your planets, they're elliptical in nature, but they don't always have the center in exactly the middle of your ellipse. Our ellipses, for this purposes, will be exactly in the middle. Number 15, you had to complete the square. Okay, so organize them. Put your x's, but put your x's together. Guys, if you didn't do this, work this out with me. Put your y's together. Let's work this together. Move this guy to this side. Now, you're going to complete the square. So, here I need 1, here I need 1. In order to do that, my x has to be 1. And even on that test, you had a negative out there. You have to get rid of that negative. It has to be a 1. Coefficient has to be 1. So this little grouping, I'm going to factor out a 9. X squared, factor a 9 out of here, plus 4x. From here.
No, not that 36, but when you after you complete square.
Because when you come over here, you can't add 4. You have to go 9 times 4. You have to take it out of that parentheses. So you were doing it right, you just forgot to distribute. And once you see what you did wrong, guaranteed you won't do it anymore. So this is plus 4x plus something. What do I take out of here to give me a y of 1? 4. So y squared minus 6y plus something equals negative 36 plus something plus something. Now, stay inside your parentheses first. What's half of 4? 2. Positive 2. I'm covering this 9 for a minute. What's 2 squared? 4. Now, that's trapped. inside that parentheses. If you want to take that out, you have to distribute it out first because all of this came up here. So 9 times 4 is 36. That's what gave you your perfect square there. Now 9, make sure you bring that down here. Make sure you bring that with you. And you kind of have to remember with the ellipse, if you didn't have a number out in front of it, it's going to look like a circle. Because then they'll always be the same. They'll be 1 and 1 all the time, right? So it's going to look like a circle. You want this to be an ellipse. So now, plus 4, what's half of negative 6? Negative 3. What's 3 squared? 9. But it has to come out of here, so 4 times 9, 36. So this cancels out, and that's equal to 36. Now we notice that your ellipse has to be equal to 1. So divide everybody by 36. This is where these come out, and then you get a denominator. 9 goes into 36 4 times. 4 goes into 36 9 times. Here's your equation. You should have nothing in front of this x right now, unless you had a fraction there. And I'm not going to give you a fraction. I hope I didn't give you a fraction one. I might. Just to throw something in there. Okay. Now, pull out the vertexes at the center the same way you pulled out your vertex, the opposite way. Negative 2, 3. That's your center. Start here. Translate your axis. Find your A, B, and C. A is the largest number. This is your A squared. This is your B squared. Remember, if it's squared up on top, it's squared underneath. That's a good way to remember it. So you remember to take your square root. A lot of times when the numbers are larger, like 25, 16, if you didn't take the square root, we'd have a hard time graphing them because we'd need a lot bigger graph. So that's kind of a little hint. Then find C. C, it turns out to be the radical. So here's my A, B, and C. From there, I can build my vertex, my co-vertex, and my foci points. Your foci points have to be on your major axis. 9 is bigger than 4, so the y translated axis is where I'm going to locate my foci points. Once you get there, can you find the rest, the other pieces? No? Can everybody find those pieces? That's not the bad part. It is sometimes not the prettiest part, but the plus or minus with a whole number, I know you guys like that so much better than doing the radical, but with the radical, you can just leave it like that. You don't have, there's nothing to resolve. Okay? Does this make any sense here? Okay. Not so bad, right? We just took your parabola and complicated it a little bit. Okay. So, 17. We grouped your x's together, your y's together. Now, factor out the leading coefficient for your square. Factor this out, complete your square, and then don't forget to distribute this to the other side. Now, this one did come out with a little bit of a fraction in here. Because it didn't divide out evenly. However, the square root of this wasn't so bad. And because, I don't know if you did this, but because we want this coefficient to be a 1, it's like just flipping it over, like a keep change flip type thing. It's just going to divide this. If you divided this top by 16 and you divided the bottom by 16, you get rid of this 16, you put it on the bottom. I'm not so concerned that you didn't get the fraction. I'm sorry? That's the part that had a hard time getting this to the bottom. If you want to get rid of the 16, like you know how you can multiply the top by 2, the bottom by 2? You can also divide by 16, divide by 16. As long as you keep it consistent in your fraction. And that'll help you get your A, B, and C. Without that, you didn't get the correct A. Or you get the A in this case. And this is larger than 1. 25/16 is larger than 1, slightly larger. So that's your major axis. This one was a little bit more like working with the fractions, but your square root came out nice on that one. If you have to, you can convert that to a decimal, 1.25 if you have to, because that one converts. I like you to use the fractions, because not always do they convert nicely. Questions? No, I reduced it. Alright, so let's move on to the next one. Okay, this was nice. Now remember, you have to be equal to 1. You know this is an ellipse because you have an x squared and a y squared and a plus sign in the middle. And your coefficients are different. If your coefficients were the same, you have a circle, which is still an ellipse, but we have a circle. So divide by 15, you need it equal to 1. Now, yes, this kind of left you working with a lot of radicals, but radicals work the same way as your other ones do. And luckily, your vertex was at the 0, 0, which made it nice. So 0 plus or minus radical 5, 0 plus or minus radical 3, and 0 plus or minus radical 2. They all worked out kind of nice for you because you had the 0. But remember what your format looks like. It's equal to 1. X squared plus y squared. The coefficients are different. That gives us a different denominator. And radical 5, radical 3, radical 2. You ended up with all radicals. But are you okay with this one? Alright. And I think we have one more. One more. This one was, the only not so pretty part about this was you complete the square. But it works okay because you don't really use that half too often until you come back down here. So half of -1 is -1/2. 1/2 squared is 1/4. When you multiplied this, it gave you 3. So that wasn't so bad. When you divided by 60, they all came out nice. Yes, they left you with the a squared of radical 5, and then your b is going to be a radical 5, and your radical 3, and your a is going to be a radical 5, and then your c is your radical 2. But when you get to this part, if you just give me a plus or minus thing in here, I'm fine. Because you can't resolve it anymore anyway. So your vertices, you just did this. That's fine. Your co-vertex, 1/2, -1 plus or minus radical 3, that's fine. It's your same concept all the way through. Notice the numbers just got a little bit creepier. They're not as nice. But your concept stayed the same. Can't do too many things at the same time. Okay, so now, we're going to start with your sketch so that we know where our major axis is. And then we're going to build just the skeleton of your thing. So we're going to start here. I have a vertices of 0 plus or minus 8. So I'm at the 0. Which way am I going? Up or down or sideways? Up and down. Good. So this is my 0, 8. This is a vertex point. This is my 0, -8. This is a vertex point. My foci should sit on my major axis. Which one is my major axis? Why? How did you know that? Because it's a that's where my major axis is, my vertex point, right? So very good. So my foci goes here, 0, 4, and down here, 0, -4. So somehow my ellipse is going this way. I just don't know how wide it is. So I need to know an A, a B, and a C. A is the distance from the center to the major vertex. So what's A? 8. B is the distance from the center to the co-vertex. That we don't know yet, right? C is the distance from the vertex to the foci. 4. Now, I have a little formula that says C squared equals A squared minus B squared. So if I know 2 of them, can I plug it in and find the third? There you go. 4 squared is equal to 8 squared minus B squared. Now I'm going to subtract 64 from both sides. And I'm going to get what? 48. Negative 48 is equal to negative B squared. So divide by negative 1. So B squared equals 48. And take the square root. Whoops. Gotta reduce. So perfect square, not so perfect square. If I divide by 2, I get 2 and 24. Divide by 3, what do we get?
16.
16 and 3. So 4 radical 3. Now, keep track of your B squared. Keep track of your B squared. You said my major axis is my y-axis. So I'm going to start like this. Our center was 0, 0, so can I start with this? Just like this? My center is 0, 0. My y has to contain the larger one, so y has to be a squared. This guy has to be b squared. C does not factor into this part. So watch how nice this is. X squared plus y squared equals 1. What's a squared? 64. What's b squared? Right here. Look, what's b squared? 48. B squared is 48. There's the equation of my ellipse. Okay? Not so bad? That's it.
That's it?
Well, I'm about to change the vertex. So I used to start simple, right? We started simple. We always have to make it just a little bit more difficult, yeah. Just a little bit more. Okay, ready for another one? Come on. Okay, so find the standard form of an equation of an ellipse whose foci, I know the foci. So let's do the foci. 0, 1, 0, 1, and 4, 1. Guys, hello? That's my foci points. And the length of my major axis is 6. Okay, leave the length of your major axis alone a minute. Where do I find the center of my ellipse? In between both of those. Hey, Daniel. In between both of these guys. So how do I find the guy that's in between them? Count equals. So there's 4 all together. So what's half of 4? 2. So my center is what? 2, 1. Okay? My center, right? Now, is my major axis my x-axis or my y-axis? X, because that's where you have to find your foci on. Now, here's another piece of information. The length of this whole axis, before I go like this, is 6. It would be 5, 1, and negative 1, 1. How'd you get that, Daniel? Okay, I said 6, but Daniel says, what's half of 6? 3. So Daniel said, if this entire length is 6, he took half of it, 3 over here, so he added, oops, where's the center? I put it over here. 2, 1. Add 3 to this guy, 5, 1. Subtract 3 from this, -1. Very good, Dan. Very good. Now, I therefore know A. A is 3. I know C. C is how many between my center and my foci points? How many did we say this was? 2. I don't know B. How can I find B? C squared minus A squared minus B squared. Right? We know one little formula that's going to help us out. So 4 is equal to 9 minus B squared. So -5. And B is equal to radical 5. B squared is equal to 5. Remember this guy. B is equal to radical 5. But we don't have to worry about graphing that unless you want to. You can graph it and come down to your co-vertices. But we know your major axis is your x. So x minus 8 squared, this is over a squared. Y minus k squared, this is over b squared, equals 1. Your center, 2, 1. A is 3. What's a squared? 9. B squared is what? 5. B squared is 5. Before we took the radical. B is radical 5. So radical 5 times radical 5 is 5. But we knew b squared already. So we can pull out your b squared out there. Okay? So any questions?
No.
I think that's the only one I have.